migratory birds, honeybees, schools of fish, locusts, ants. What do all of these life forms have in common? Did you say that they all participate in movement patterns which can be simulated deterministically through code? I'm sure you all said that at your screen in unison. Anyways, today I'm going to talk about bird-oids or boids. Boids are super interesting because of the organic flocking patterns that emerge from basic programming. They essentially follow three simple rules: alignment, separation, and cohesion. Alignment basically says that you should sort of steer in a direction that matches those around you. Separation means to avoid crowding your flockmates by slightly turning away from those closest to you. Cohesion is kind of the opposite. It says that you should steer towards the center mass of the flock. Weights are essentially a value that represents how much we adhere to these rules, and varying these weights changes the behavior of the flock wildly. Now that we know the rules of creating a flock, let's actually make one. After some basic setup, I started out by creating a sort of stretched triangle to represent the boid and its direction. Next, I created a boid manager to handle the instantiation and storing of all the variables. My first thought was to have the boid manager send each boid its own weights to try and avoid passing variables each frame. However, I really wanted the functionality of being able to change the weights of the flock in real time without resetting the simulation. It seemed I could either A, send each boid its own weights from the boid manager every frame and have the boid store it, or B, access the boid manager inside the boid's logic script without storing it so that the weights update dynamically. I went with option B to save on memory because I eventually want to get this running in a browser. I started off by creating a bunch of boids with a random direction and a speed value that I could control. Next, I introduced a bit of random motion by changing the boid's direction by a small random value. But how do you align to your flockmates if each of them is pointing in a different direction? Well, first take all the boids in existence and find out which of them are in a discoverable radius. These are the boid's local flockmates. Then you can add up the headings of all your local flockmates, divide that by the number of flockmates to get the average heading. Now we just interpolate towards that average heading based on our alignment weight. Initially, I tried to do the same thing with cohesion by averaging our flockmate's position and interpolating to that value, but there's a major issue with this. Simply moving towards the average vector completely ignores the direction that the boid is facing. i.e., boids can move toward each other without even looking, which is mega weird and totally unnatural. A better solution lies in computing what the direction should be, according to its current direction, the flock's position, and the cohesion weight. All we have to do now is interpolate between our current direction and a direction that points directly towards the flock, and the boid will eventually be pointing towards it. I got some pretty interesting flock behavior by tweaking the weights, but it still has some issues. A major one is the separation. Boids can get impossibly close and spin in circles forever. I'm gonna go ahead and say that most birds don't have that issue. Another issue is that boids often drift outside of the camera's field of view, and I don't really want to write a fancy schmancy framing script. So I'm just going to loop the bird's position to some arbitrary limits outside where the user can see it. This worked up until I realized that they're sticking around the edges, teleporting from one side to the other every frame. Luckily, I was able to fix this by adding a margin just to make sure they didn't wrap around to the other side the previous frame. Interestingly enough, the way some of these boids moved looked like different animals or insects depending on the system weights. For example, with high separation, low cohesion, and low alignment, they looked like ants or maybe mosquitoes to me. High alignment, low cohesion, and high separation kinda looks like schools of fish. High cohesion, low separation, and medium alignment looks like vultures circling around their prey. I don't know, I just find it incredible that changing some simple rules can get humans to recognize some moving triangles as the same movement patterns found in nature. By giving the separation rule a small radius around each boid, I was able to create a lot more realistic looking patterns. At this point, the sim is mostly complete, and now it's time to add some simple UI so we can change the weights with sliders. And just to make things a little bit fancier, I gave each boid a small trail renderer so we can see where it came from. However, there is a minor problem. When a boid wraps around the screen, it leaves a streak from the side it was previously on. It looks really cool, but I might have to turn this off in the future unless I can fix it. Later, I ended up adding wall avoidance, which fixes 90% of the wrapping or streaking issues. Next, I added two new functions in the boid logic. Target force adds a force to seek out targets, and obstacle force adds a force to avoid obstacles. These aren't super interesting by themselves, but the effect is definitely noticeable when I set the target's position to the mouse. Alright, that's cool and all, but the triangles are getting a little bit boring, so I'm going to draw a koi fish animation to put over it. I started out with the skeletal type animation, but I decided to simplify it by just drawing a left, middle, and right pose. After I imported it into Unity, it looked pretty weird because all these animations were syncing up and overlapping with each other. To make sure that these animations can't be in sync, each Boid has a unique animation speed. I also changed the collision radius so that the fish avoid each other sooner. Now they look like fish, but they don't really act like fish. It seems like fish prioritize staying in the same direction and being the same distance apart the most, so I'll change these parameters first. And with some tweaking, these are looking like fish for sure. I almost forgot to mention, if you want to mess around with this simulation, I put the link in the description. Thank you for watching. I hope this video was cool or at the least informative for you. If it was, please consider liking the video or subscribing to my channel for more. See ya!